Hi everyone. As we have midterm next Monday, not next Monday, on 8th of November, on lecture, or instead of lecture. So I would like to show you examples from previous years of midterm tasks. Anyway, midterm task consists of design task, and design tasks come divided into two distinct tasks. And first task is to build or draw an entity relationship diagram for a given domain. And second task is to build logical model, build a relational database scheme in form of create table scripts, in form of script with create tables. So if you don't like AR diagrams, so you may immediately go to create tables. So first, if create tables are here, then task one considered done, but not vice versa. If only ER diagram, and ER diagram may be translated into logical models in different ways. So so that's not a relational database if you draw only conceptual model. Conceptual model may be translated differently. So task and some queries to your model, to your database that you designed in first two tasks, you need to combine, to write down SQL statements, select statements. So first task here is about modeling of companies that has a few branches, and each branch in a distinct city. So we may say that branch to city is one-to-one relationship. So each branch is in a city, and each branch in a distinct city. So no cities with two or more branches, and no branches in two or more cities. And time to time, employees go to business trips from one branch to another. And so we may say that as branches and cities are one-to-one, so we may say that branches and cities is the same, and we may call branches, let's say, with city names. So trips is between cities. Trips are between cities. Each trip has planned date, planned start date, planned end date, fact start date, and fact end date. So couple of dates, and a task, and task assigned to it, that's just a string to go there and do something. So that's just a text, a textual column or textual attribute. Trips may be canceled, but only before it start. So if trip is already started, then we can't cancel it. It just will be ended earlier. And if we cancel a trip, then date of cancellation is to be recorded too. So that's fifth date. We have 4 dates, planned and fact pairs of dates, and possibly cancellation date, or just no cancellation date and cancellation, some cancellation flag being set or not. For each trip, travel department reserves a pair of flights and books a hotel at destination city. So and for each flight, we know its origin and its destination, air company, flight number, date and time of departure, and ticket price. And a hotel has name, address, city, room charge for overnight stays. So that's it. First question is what we want to store, what are entities. You can say that we have company, and company, they don't tell us, and that task description don't tell us that we plan to create a service or software as a service system for multiple companies, just single company. So we don't need to store anything about company. Then branches. We don't know anything about branches besides their cities. So probably we don't need to have a table of branches, as we have just single column of city, and the same. So Moscow branch, St. Petersburg branch, and so on. Business trips, yes, that's a table. Trips for that, or that's an entity, business trip. And what we have about business trip? I have employee, we have probably employee ID, and then we have from city or source branch or starting branch or branch to go from, or I would like to call this column from city from, or from city, and destination. So city to, let's say city to. So employee ID, city from, city to are columns or attributes of this entity of trip. And then for dates, for planned and fact, start and then dates, task being string, cancellation flag, or just a column cancellation date that can be null, and that's it. And null means that's that trip is not canceled. And what about pair of flights? Probably we, let's see, let's think about relationship between trips and flights. Each trip connected to pair of flights, exactly two, not single flight. We can't have trips without flights. So each trip has exactly two flights. So one option is to have a table. I would like to speak in logical model terms. So we have a table of flights and two references to it, or flight IDs maybe, or ticket IDs in trip table. And second option is to have just all the data about both tickets in the same trip table. So trip table in this, that's my preferred option. So our trip table will contain, for each flight, we need to know origin and destination city, and we don't need to store them once again, as we already have trip city from, trip city to. That's exactly origin, flight origin city, and destination city. So we don't need to store them in one more time. Air company, flight number, date and time of departure, and ticket price for flight there and for flight back. Couples of columns. Or if you extract or put it aside in another table, that's not an error. That's just two different options. And just for different queries, we need to, in second option, we'll need to join these tables. That's possible too. That's completely good. And if we think about normalization and we think about normal form conformance, then both options are normalized. So up to third normal form, having all the tickets, both tickets in one table and having both tickets in different table. And what about hotels? Each hotel has room charge, and we may expect that room charge is different. If my employee goes to the same hotel at different times, I may expect that a hotel has floating rates, and in low season they set a lower price for their rooms, and for high seasons they may have this price twice as big or triple as big. So different room charges for even for the same room may be expected. So having a table of just hotel, and these charges may change not regularly, but at will of hotel owner. So, but at the moment of booking, of hotel booking, I know this charge. So probably I would like to store hotel name and address and room charge for each trip individually. I can't build a dictionary or the whole list of all the hotels across the whole world, and they're all room charges, so I don't need it. At the moment of booking a hotel, I go to booking system, and then I have my data and put it in just single table and the same table of trips. So I would like to store everything about hotel, including name, address, and maybe I don't need address, I need just city. If I look at my queries, I don't need addresses of hotels, and I know that city of hotel is exactly the same city as destination of this business trip. So I don't need to store it once again. So I need to store hotel name and room charge. That's it. So that's logical model. Essentially just single big table of trips and store everything about trips. Each trip, employee IDs, city from, city to, couple of dates, cancellation date, task description, flight to, first flight air company, first flight number, first flight departure time, first flight ticket price, second flight the same things, hotel name, and hotel room charge, and that's it. So for queries, and looking for queries, find all hotels in Paris booked by employees from Berlin in current calendar year. So they're just simple single table select query with just where condition. I put in where condition city from equal to Berlin, city to equal to Paris. Let's say fact start date, year of fact start date equal to year of now or current date. That depends on your system, but you may use anything, or just put equal to 2021, and that's it. And or just select hotel name and probably distinct hotel name, and that's it. So that's just simple query with just where condition, no joins, no grouping, and only thing is distinct. Fourth task number 4, find company spending on hotel bookings in previous months and group by city of hotel. The same thing, I need to select from the same table. I just have single table, so all my selects are from the single table. I need to group it by city, city of hotel. So that's destination city, that's city 2. So select this group by city 2, where condition on previous months. So where before group, I said where fact start date, months of fact start date equal to current month minus 1. And I want to find spending, how much money is spent. So to calculate it, I need to, for each trip, I have fact start date and end start and fact end date. I need to subtract end date from start date from end date, and I have number of nights in the hotel and multiply it by room charge, and then sum it for each, not for each, for the whole group. So select sum of end date minus start date, multiply room charge, that's under sum function, from trips where months start date months date part of from start date equal to previous months of current date, and group by city 2. That's it. Next task number 5, is the same thing, but just group by city from and nothing else. Sixth task is to find top 3 branches by number of trip cancellation, but not all number of all trip cancellations, but only we want to see only late cancellations, not early cancellations. So 3 days before and not more, just in last days. If trip is canceled just last day before starting, or 2 days before starting, or 3 days before start date, that's not too good. Probably we need we can't return our money for reservation or something. So we want to find branches that that cancel trips late. So how to check? The same thing, that would be grouping by branch. So group by city from and branch of departure, city from, where cancellation date is not null and cancellation date minus start date lesser than 4 or lesser or equal than 3. That's a where condition. And then I have and select branch, and branch is city from, select city from, comma, count of star from trips where cancellation date is not null and cancellation cancellation start date minus cancellation date lesser or equal than 3. Group by city from. That's all the branches. And their number of trip cancellations in 3 days before trip start date. Then I need to order by this column. Let's set an ls to this count and order by this ls. And then I need to apply my knowledge how to find top 3 or top something using dense rank with over, or using just subquery, or using with. Anyway, you know it. You may find top ranking records and this thing. And the last task is about self-join. Self-join for the question of finding all the pairs of employees who traveled in the same day between the same pair of cities and in the same direction, but on different flights. So we need to send those employees in same direction on different flights. So we need to call taxis twice for our office. We need to order taxis to different taxis and send our people to airport and pay for taxi twice, instead of sending them on single taxi car, and then pay just once for the same thing. So we don't want, we need to find such situations when we send these people from the same office to the same city in the same day. Essentially, they may flight on the same flight, but somehow they we reserved or booked different flights. We want to find such issues and then to resolve our errors in future. So how to do it? We need to find 2 trips started in the same day. So where, or to find 2 trips from trip T1, join trips T2 on. Trips are from the same, so city from is the same, city 2 is the same, day, start date is the same, equals and equal and equal. Flight numbers are different, people are different. Employee ID, T1 employee ID is not equal to T2 employee ID, and T1 flight number is not equal to T2 employee number. So that's all. We need just find all the pairs, and the only thing is we don't want to list all people multiple times. So employee 1 and employee 2, and then employee 2 and employee 1. So I would like to, instead of employee ID is not equal, I would use greater than. And then I have each pair only once. And probably I don't want to have repeating pairs. These 2 people travel in the same days between same pair of cities and same directions on different flights quite frequently, multiple times. So in this case, I would need to use distinct. But that's just a partial solution, as it may happen that one employee go to a business trip from branch, let's say from Paris to Berlin, and another person go from Paris to Berlin, but that's a trip back. So second person is from Berlin office, and his or her trip is trip back to home. So and each trip has city from is starting city to is next city, and then back trip is from city to city from. So I need to maybe union pairs of employees who traveled in different direction. The aim is the same, peoples are different, cities are different, but city from in one trip is city to in another, and that's it. And city to and city to in first trip is equal to city from in another. So I need to find employees who travel in the same direction between the same cities, but for one person, that pair of cities is from and to, and for another person is to and from. So that's second part of correct answer. So I need to find such employees too, but only if I have just single table of trips with all the tickets. If I have distinct table with tickets, that would be simpler. And then I need to just go to that ticket table and find 4 tickets between same origin and destination cities in the same date, and so with different flight numbers, and that's it. And then each ticket should have a trip ID, and then I find trip IDs, and then find employees. That's a way to use another model, and for this query, probably another model would be more efficient, or not. That's a matter of query optimization and optimizer and so on. So that's it. So the whole task is for for hour and 20 minutes for the whole lecture. It may be done. It may be written manually on, and so you'll send. Anyway, all the tasks, the whole assignment will be created in Canvas, in the Canvas. So you need to upload your results there, and your results may be in form of text file, and I prefer it. And you may draw on paper and make a photo, or you may use anything. You may use Visio, you may use Draw.io and everything, and send PNG files or JPEGs or something. So that's it. So that's one of the examples, and you may look at another example, task set C. That's about car sharing company, and that's almost the same thing, but a little bit more complex, as we have car sharing trips and cars, essentially 2 different tables, but it's just a little bit more complex, and complexity level will be around this task, not too much, complexity will be just like this. So our first task is to build a model, and then create tables, and then 5 queries, and some queries with grouping, and one query with just filtering, like task 3 here, 2 queries with grouping, one query with top something, and one query with self-join or just joins. So that's it. So thank you, and please prepare for, if you have for our Monday midterm, and if you have questions, please send me, and I'll answer them. Thank you.